Alright guys, so I'm going to go over this aftermarket LED board and show kind of how you can determine how these chips are wired, determine the voltages and all the specs of everything. Here they've wired them in an array, so there's an array of 28 white LEDs as well as an array of 27 amber LEDs, and basically up top you have 10 sets of LEDs that are in series. You have one that's by itself, and then you have every three are wired in series, getting its power. I didn't analyze the amber ones yet, but I'm sure it's the same. And you can tell this two ways. One, if you look at the lines on the board underneath the magnifying glass, or if your eyes are good enough, you can kind of see how they're wired based on the lines. And then also I'll show you how you can kind of determine that just by using a multimeter. So this application here is basically a switchback functionality. So there's your white DRL, and then it doubles as a switchback sequential turn signal. So if we leave it on white, and what I'll do is we want to determine, one, how these LEDs are wired. So we know there's 28 individual chips. So what I'll do is I'll take the multimeter and I'll check the voltage on that first chip. Look at the meter over here. So you can see the voltage on that first chip is 2.7 volts. So now what I'll do is I'll check both chips here to see what happens, assuming or not knowing if they're in series or if they're both standalone or what have you. So now the meter on both chips still shows 2.7. So I'll go over to the third chip and check that, and now the meter shows 5.5. So we know that each one of these chips is 2.7 volts because you can check each chip individually, and the voltage reading you'll get on the meter will be 2.7 volts. So that's what's being pushed or pulled through these chips. So knowing that when you check these first three chips in a row you only get 5.5 volts, that doesn't make any sense. So let's check the next three chips, and the meter shows 8.3 volts. So we know that 2.7 rounded up multiplied by 3 in series is about 8.3 volts. So that tells me that the first chip here that reports 2.7 volts is by itself as a power source, and then these next three here in series are reporting again the 8.3. And you can double confirm that is, let's go back to just two chips here. You should get the 5.5. So you have the 2.7 in series times 2, that's your 5.5, and then you have again that third one in series here, and that's your 8.3. Now watch what happens when you move to that fourth chip and you're trying to measure the voltage in series. You're back down to 2.7. So that's how you can determine that that first chip is a standalone chip, and then you have 3 in series, 3 in series, 3 in series, all the way to the end of the board at your total of 28 LEDs. So, and you can do that math too. You could take to try to determine how much power is being pulled through here. So if you look at my power supply at 14 volts, my meter here is reporting 320 milliamps. So if you actually take the 28 LEDs and you take the 9 sets of 3 to get your 27 LEDs, and then you have the standalone for your 10th LED, so that's 10. If you multiply 10 times 30 milliamps with the assumption that these are 20 or 30 milliamp LEDs, you get about 310 milliamp power consumption or amperage consumption, which aligns with the total circuit being noted here at 320. So I'm not sure if the camera will pick this up, but if we actually look through the magnifying glass, you can kind of see how maybe with these lines that first chip is isolated with the power and ground inlays there. And then when you look here with every 3, you can see how there's a pattern, how they're grouped together with the lines inside the PCB, and the next 3 that are kind of grouped together. So that's how you determine how these LEDs are wired up. in the array that the configuration that they're wired in. And to add to everything we just determined, if you actually look in the back of this board, you can see that you basically have 4 wires extending to this separate PCB for your remaining, what was that, six LEDs for each color there. If we turn these back on, right, obviously you're going to have a ground and a power and a ground and a power for each color there, for each LED. So a ground and a power for white and a ground and a power for amber. So let's, with these on, right, knowing that we have 6 LEDs powered up there, both in 3 in series and 3 in series, if we check the voltage between the 2 power sources here, you can see that meter again equals the 8.3 volts, which is shared across those 6 LEDs, because they're both, you have 3 in series times 2, and they're both in parallel. So that's how that math works. As far as the back of this board, still trying to kind of learn this stuff myself on the fly. Whole bunch of components I don't even know. Looks like a lot of resistors. I guess this is kind of the main IC that does the sequential magic of the amber, or maybe that's the driver. I'm not sure. And this is maybe that sequential IC. Not very sure, but yeah, hopefully this helps someone to kind of how you can determine how things are wired. And if you really wanted to, right, you could, I guess you could start, get a Dremel or a X-Acto knife and kind of start scoring those connections and wire in a resistor for each one to kind of sequence these yourself with Ghost or any other type of LED controller. So we're not going to do that. We're actually going to take all these off and replace them with some different chips and do something a little different. That's it. Alright, so what I did here to prove out my assumptions earlier on the 30 milliamp current consumption per chip here, or per series of chips, to total that 310 that the entire meter was saying it was pulling, or power supply was pulling rather. I desoldered the last chip here for the last 3 in series, and obviously you can see by doing that, the last 3, well, you have the 2 here and then the 3rd one on my wire here, but they're not getting any power at all, obviously, because there's no circuitry connected there. So I'll put the meter, my amp meter, in between on this last chip here to make the connection on the last 3. And if you look at the meter over there, you can see that when it's on, you have 28 milliamps, which aligns with the 30 that I said. So that's pretty much how that works. Cut it, Paz!